And there have been several notable weather events since then, including last year, 2024, and even this year, where people have decided, okay, this is another extreme, and this is a signal of how the climate is changing and how our understanding of weather might need to change in Antarctica.
Hello, and welcome to this episode of Beyond the Ice. My name is Em Newton, and this is the podcast from British Antarctic Survey, where our experts brief you on newsworthy polar and climate science. Today, we're asking, how do scientists actually know that Antarctica is melting? This might seem like a basic question, but there is lots to unpack here. At the start of May, news outlets around the world covered research from Tongji University in China that showed that Antarctica's ice sheet had gained mass between 2021 and 2023. Now, if you are one of the brave souls that ventures into online comment sections, you may have seen that this finding has become a regular point of argument against other stories about climate change in Antarctica. So, how is it possible that Antarctica has gained so much ice? Does this research suggest that the future for Antarctica and global sea level rise could be better than expected? And how do scientists actually measure ice loss at a continental scale? To take us beyond the headlines, I'm joined by Dr Michelle Maclennan, a climate scientist at British Antarctic Survey. Michelle specialises in extreme weather and its impact on the Antarctic ice sheet. Thank you for coming on the podcast.
Thank you so much for having me. I'm excited to be here.
Oh, fab. Okay, so let's start with a really basic question. What is the Antarctic ice sheet?
I think that's the biggest question of them all. It matters the most, right? So Antarctica is a continent at the very bottom of the world, and it's this huge block of ice that's resting on a continent. It's really thick, so in some places it reaches 4 or even 5 kilometers, so it's very, very thick ice. But yeah, it's very much removed from the ocean where it sits on the rock. So we have things like sea ice, which is ice that sits on the ocean surface, and this is not that. This is ice that sits on rock, and it's mostly removed from the ocean, although at the very edges of the continent, that ice begins to interact with the ocean as well. The way that ice interacts with the rest of our world through the climate can impact all sorts of conditions throughout. So, for example, sea level rise or weather patterns or animal migration.
So Antarctica is effectively this huge storage location for a huge quantity of water then, kind of sitting on the land. So when scientists talk about the changing amount of ice in Antarctica, they use this phrase, mass balance. What does that mean, and why is it such an important measure for climate scientists?
So the term mass balance sounds complicated, but it's actually really simple when you come down to it. What it means is that we're looking at how much ice is stored in Antarctica and how that changes over time. So the word mass refers to essentially the weight of the ice. And when we think about how that mass is changing over time, the ice sheet can gain mass or gain weight, or it can also lose it over time. And that's important because when Antarctica loses that weight, that mostly means that the ice is flowing from the continent, from being stored on the rock, to being in the ocean, and that contributes to sea level rise. And so what we've seen in recent decades, since the 1970s, is that Antarctica has been losing more and more ice over time. It's called mass loss, and that is contributing to sea level rise. At the same time, though, there is a lot of change in the amount of ice in Antarctica year to year. So some years we see actually some gains. Most years, though, we see a lot of losses.
Okay, but how do you actually measure the amount of ice that is present across the continent? Because that's a huge area.
So satellites that are flying over Antarctica and looking down at the ice can take some measurements of how the ice is changing. And that can give us an indication of how much ice is stored there and also how that's changing. So one of the ways is that you can use gravity. So because Antarctica weighs so much, that ice weighs so much, it actually exerts a bit of a gravitational pull.
Oh, wow.
And so when that pull changes over time and changes in certain regions of Antarctica, right, we definitely see strong regional differences.
Wow. And so that's helping you understand from the sky how thick the different regions of ice are and how those different thicknesses are changing.
Yeah, essentially from space, it's telling you like what areas are losing ice and what areas are gaining ice. And that can result in very big changes to the surface or how thick or thin the ice is as well.
Yeah. How do you measure gravity?
That's a great question. It's a little bit beyond my payroll. What I would say is there is this satellite mission called GRACE. And these GRACE satellites consist of 2 satellites that orbit in close succession to each other. And it's the interaction of those 2 satellites with each other with the gravitational pull of the Earth's surface that can then track how changes in gravity are occurring over time as well.
Okay, interesting and complicated.
Yeah.
Okay, so let's go to this study that hit the headlines. It was published in Science China Earth Sciences. It says that the Antarctic ice sheet abruptly gained mass between 2021 and 2023, and that's despite warming temperatures and obviously that history of decline. Can you explain a bit about what they found in this paper?
Yeah, I think this is such a cool paper, and they actually do rely on those gravitational satellite data we just talked about to look at how much the change in ice mass is over time. So basically what this study is doing is it's tracking changes in the ice mass in different parts of Antarctica over several decades. And what it found most notably is that some parts of Antarctica, especially East Antarctica, have lost a little bit more ice in, a recent decade from basically 2011 to 2020. But that other areas of Antarctica and this one saw kind of a resurgence following that in the past few years. And so there's a bit of a change in the trend in the mass balance. And that's interesting because that, again, has all these implications for sea level rise and how much Antarctica is contributing to sea level.
Have we seen an increase in mass balance of that scale before? Do you know?
I think it's pretty clear that since the 1970s, the mass loss has been pretty intense from Antarctica. So we've seen a lot of ice loss to the ocean. And basically year after year, we've seen, less and less ice being stored. But then what happened in 2022 is that we had a very extreme storm that hit part of Antarctica, and it brought a huge amount of snowfall to Antarctica, more than we had seen from most other extreme storms before. It was very unexpected. And that actually caused us to see an increase in the mass of Antarctica for the first time in decades. So that was really impactful. And that's a big part of the reason why this paper is also showing this trend, is we've had some of those extreme weather events in recent years that are causing that signal.
Yeah, and again, this is a huge amount of ice. So in the years 2011 to 2020, the ice sheet was losing an average of 157 billion metric tons a year. And then in this 2-year period, in that period of extreme weather, the ice sheet started gaining mass, and it gained about 119 billion metric tons a year. And that's enough to temporarily offset some of sea level rise. So that's an extreme storm.
Yeah, absolutely. So, and we actually saw multiple storms that are contributing to that. I think the thing that's interesting about Antarctica is we talk a lot about the ice flowing into the ocean, but you actually have to think about it as a system where you have inputs and outputs. And the output is that over time, snow accumulates on the surface, it's compacted or hardens into ice, and then that ice flows outward and flows into the ocean. And so that's our output. But every year, we're also getting a huge amount of snow as input, which is bringing water back to the ice sheet. The interesting thing is that we just have a very slight imbalance in these two processes. So even though we're talking about, billions of metric tons of ice or water being lost to the ocean or gained, what's actually happening is this is quite a small imbalance. And we just happen to have a lot of snow that falls over Antarctica each year and a lot of ice that flows into the ocean. And so this number, compared to the input and the output, that difference number is small, but it's increasing. And that's ultimately what the issue here is, that we have that imbalance. It is really fascinating, though, that in the past few years, we've seen a flip in this trend. My hunch is that it's most likely a short-term signal. I think it's very clear from a lot of the studies that have been done, a lot of the field work people here at BASS and at other institutes have done, that we're probably going to see this long-term trend of more and more ice being lost. So I'm guessing that this is a bit of a short-term reversal, but eventually we'll see that this returns to the long-term trend.
So all 4 of those glaciers in the paper, as you've said, are in East Antarctica, and they include the Totten Glacier. And then at the same time, there's all this energy in West Antarctica, scientific energy, because that area is changing very rapidly around the peninsula in areas like the Thwaites Glacier. So this paper, to me, implies that there's this ice loss still happening in the West, and then this accumulation in the East, certainly in this period. Why are they so different?
Yeah, this is a great question. So East Antarctica and West Antarctica are very different in terms of their weather and climate, but some parts of these different regions still have the same vulnerabilities, which is why we're starting to see some warning signals emerging from East Antarctica that are more familiar with the West Antarctic system, right? So, for example, when we study Thwaites Glacier in West Antarctica, I was part of the International Thwaites Glacier collaboration, and a large focus of this project was to look at the vulnerability of this glacier to warm ocean water that's flowing right to the very front of the glacier and melting it essentially from below. And what this paper is highlighting is that there are parts of East Antarctica that are vulnerable to the same processes, and we're beginning to see some signals that warm ocean water is starting to impact the Totten Glacier region as well. That said, though, East Antarctica is a huge, huge part of the continent, and this is just one region of East Antarctica. And so East Antarctica is much bigger than West Antarctica. It's also much colder and drier, and it's a very different climate system. And so this paper shows it is really helpful to look at these regions differently and approach them understanding that you're in a slightly different climatic context.
That's really interesting, because I think in the media, there's not a lot of room for this kind of nuance. People just say, oh, Antarctica, it's melting at large. And no one really lives there. So people don't have any sort of context for the geography of it at all. But it's the 5th largest continent, isn't it? So it's larger than Australia, and it's larger than Europe as well. And you'd never expect those places to have a completely uniform kind of climate and environment.
Yeah, no, absolutely you wouldn't. I mean, so I'm American, and you could fit the entirety of the United States, the continental United States, inside Antarctica, and you would still have room to spare. So this is a huge area that we're talking about. And even though it's at the bottom of the world and feels pretty far removed from our day-to-day life here, it is important to talk about regional differences and to discuss what parts of Antarctica are more or less vulnerable to changes in climate.
Okay, so in terms of those kind of regional vulnerabilities, you recently published a paper about extreme precipitation events in Antarctica, and your conclusion was that we'd probably see a doubling of extreme weather events by 2100 in Antarctica. And crucially, one of your conclusions was that this will lead to a lot more precipitation, rain, and a large amount of snow. So based on your current research, do you think we can expect more events like this, particularly in East Antarctica?
Yes. So what I study is extreme snowfall in Antarctica and weather events, and we see those as being very closely tied to climate change through changes in the temperature. So what happens when you increase the temperature of the air is that the air can hold exponentially more moisture or water than it could at a lower temperature. And so what happens is when you warm the planet, we see that the atmosphere can hold a lot more moisture. And that means that the storms that we have that are transporting moisture, like snowfall and some rainfall, all the way to Antarctica, can carry more and more of that snow.
Okay.
And so when we think about how much snowfall may increase in the future, we see a very close relationship between snowfall over Antarctica and increases in temperature due to climate change.
Cool. And you talk about something called an atmospheric river. What's that?
Yes, atmospheric rivers are so cool. They are basically these like supercharged bands of moisture in the atmosphere. So what happens is that you can have some storm systems that have so much moisture concentrated in them that it's like having a river in the sky. And when that river in the sky makes it all the way to Antarctica, which doesn't happen all that often, it can dump an extreme amount of snowfall onto the surface of the ice. But because it has this concentrated band of moisture that is transported over a long distance, these atmospheric rivers are also associated with very high temperatures. And so they tend to bring a lot of heat to Antarctica as well. So they're generally seen as events that can have mixed impacts. But the cool thing about them, the coolest part, is that they can bring so much snow to Antarctica that they can really help to offset some of the sea level contributions that we're seeing. That's their superpower.
Based on stories like this, would you expect the entire ice sheet to melt? Or is this kind of showing us a pathway where actually we can see a lot of melt being offset in this kind of slightly unexpected route?
Yeah, I think that we've seen that there are some clear, almost like structural issues with the ice in Antarctica now, where it's flowing into the ocean faster and faster over time. And even though we'll likely have a lot more snowfall in the future as well, that's probably not going to be enough to completely offset the sea level rise that we'll see from Antarctica due to that ice loss. That said, though, what we really want to know is how much sea level rise will occur in the future. And in order to actually come up with those numbers, you need to know what's the balance between the snow and then the ice loss. And so even though there have been a lot of studies on this, up until now, there's still a lot of work that needs to be done in terms of narrowing down our estimates and understanding what the sensitivities are so that we can produce, a closer estimate to the types of impacts we all might experience in the world.
And I guess with extreme precipitation, obviously it can also fall as rain, even though it's in Antarctica. Is there an extreme difference to what impact that has on the continent, whether or not it's rain, snow?
Yeah, absolutely. So rain can be very damaging to the snowpack in Antarctica because it's liquid falling into something frozen. So it can cause some more melt or it can cause warmer conditions. So generally, while snow benefits the Antarctic ice sheet, rain can in some extreme cases actually add to the amount of ice that is lost. And so at some point, if we reach temperatures high enough where we begin to push Antarctica out of, the frozen regime into a melt regime, then we might actually see much more widespread melting and even higher sea level contributions. I think that's still a bit of a ways off, but it also really depends on just how much our planet warms, in the next 100 years or so.
So this study that we've been talking about is talking about findings from 2021 to 23. It's now 2025. Do we actually know what's happened since? Have there been similar extreme events that we know about and we can expect papers on in the future?
Yes, there are always interesting weather events happening in Antarctica. And I think we are actually moving towards a system where people are doing a better job of monitoring weather events as they occur. So, for example, when this big storm happened in March of 2022, there was an immediate response from the scientific community to come together and study this event. And there have been several notable weather events since then, including last year, 2024, and even this year, where people have decided, okay, this is another extreme, and this is a signal of how the climate is changing and how our understanding of weather might need to change in Antarctica. So, for example, in May of this year, actually, just 2 months ago, there was another rather extreme atmospheric river event that happened in West Antarctica. And the team I'm on decided to look into this event and look at not only what caused it to happen in the atmosphere, but also what some of the wider reaching impacts of the event were. And I think that kind of quick turnaround or active monitoring of Antarctica is really helpful for having some early warning signals when we do see rapid changes occurring as well. In a similar vein, the team that I worked with in the International Thwaites Glacier collaboration are constantly monitoring the Thwaites Glacier region for changes. They look at pictures from satellites all the time of this area. So they're really ready to document if a big change happens.
Cool. So looking ahead, is that really shaping the research that you'll be doing in the future, or are there kind of other key uncertainties that you're investigating?
I think that this question of how much will snowfall change in the future and how is the climate system responding to global warming is a really key one that still has so much knowledge to be found. And so the current project that I'm working on is looking more closely at these atmospheric rivers and other storms to look, very specifically at how the storm is structured, how intense it is, and also how that might change in the future. And there's a lot of ongoing research in this field, in the field of weather extremes. At the same time, though, we also saw the conclusion of the International Thwaites Glacier collaboration this year. And a lot of people are asking, what's next? What will the next big glacier research project be in Antarctica? And I think there's an open question right now as to, what region will people focus on next? What regions will be the most important ones to look at? Certainly, the Thwaites Glacier region will continue to be very valuable to study, but like this study showed, it's well possible that more attention will go to the Totten Glacier region in the future as well.
That's really interesting. Okay, I'm going to ask the gnarly question. What do we think the kind of changing nature of polar science funding over the next decade could mean for where scientists are putting their focus?
I think no matter where you are in the world, a lot of scientists are really advocating to get more funding for polar research, recognizing how important the poles are for everyone in the world, both today and going forward. It's also quite heartening to see the success of these international collaborations where scientists across borders, across different polar programs have really come together, which helps to leverage the tools and the skills that different programs and people have to better study the environment. So I think that is really encouraging to see, and I really hope that continues going forward.
I think one of the lovely things about the 21 to 23 study actually is that it's a Chinese university and they're using data from NASA satellites. And that in some ways is the kind of ideal state of the scientific collaboration, right? It's kind of cross borders. And I think when you're in the polar regions, you see that the actual people who are there are very ready to collaborate with each other.
Yeah, they absolutely are. I think open science has been huge for enabling those collaborations. We also see in a footnote of this paper that they collaborated with a Dutch research group as well to look at a model, a computer model that shows things like snowfall and other surface processes. So it was definitely a multinational collaboration for this effort. And I think there are also other parts of the world, China included, as well as South Korea, that have polar programs that are growing and growing. And so that is neat to see that there's an increase in the diversity of the research and also a recognition that the value of the research really spans borders.
Oh, on that note, thank you so much for coming on the podcast.
Thank you so much for having me.
Thanks for listening to this episode of Beyond the Ice. If you enjoyed it, please do recommend it to friends, family or colleagues. And if you can, leave us a review on your podcast platform of choice. This really helps other people find the podcast. In case you didn't know, you can also find Beyond the Ice on LinkedIn. We publish it there as a newsletter that you can get straight to your inbox and featuring a quick summary article with key quotes from this interview. Perfect if you ever want to refer back to something in the future or you only have enough time to skim read. See you next time.